last time I told you the structure of neural networks, right? So basically the function of neural network, the neuron is very simple, right? There is a 3-step. The first step, anyway, the structure. There is a neuron. Here is a neuron. This is a neuron, and then it has the n inputs, right? x1, x2, and xn. And each connection, there is a connection way. Okay, this is a structure. Why does it have this structure? It's simple, because our neurons, our brain, it looks like this, right? It has this kind of structure. So we just try to copy the biological neurons to the artificial neuron. That's the reason why do we have this kind of structure. It's simple. We just copy the structure of biological neurons. So anyway, there is a neuron, and a neuron has n input, and there is a connection weight as a biological neuron has. So connection weight, there is. This is a structure. And the functionality or the working, the step of the function is very simple. The first step is the multiplication. So input, connection weight, input, connection weight, input, connection weight. You have to multiply the both numbers. And then second step is summation. You have to sum up all these numbers. So we can simply write down like this. The step 1, the xi, multiplication. And then step 2, sum up all of these things, right? This is step 1 and 2. And let's say this is S, a result of summation. And the step 3 is activation. The activation means to activate the output. This is step 1 and 2. And step 3 is simple. If the summation S is greater than some threshold, let's say that this is 0, and this is threshold. And if this is a threshold, the summation is higher than the threshold, then the output will be 1, which means that there is an output. 1 means that there is an output. Otherwise, that is if the summation is lower than 0. Okay, the equal sign. If you want to put down the equal sign to here, no problem. You may put down the here. Where the position of equal sign, that's not important. You may put it upper side or you may put it the lower side. That is not so important. So anyway, the summation is greater than 0, then the output will be 1, and if not, the output will be 0. So this is some kind of a binary neuron, right? Because it produces 1 or 0, one of two values, right? 1 or 0. So we may say that this is binary neurons. So you may think that, oh, the binary neuron is it looks some stupid. Why? It produces only 1 or 0, right? Because we have a lot of different numbers, but neurons can produce only 1 or 0. So it may look very stupid, but no problem. It's enough. Why? The computer we use today is binary computers, right? It produces only 1 or 0. The computer, right? The cell phone is a computer. It output only 1 or 0, but it can do everything, right? So even though this neuron is binary, it produces binary numbers, but it can do everything. So don't worry about this. Okay, later we will see another types of neurons which can produce a real number. Okay, that is another different kind of neurons, but it's okay. But still, binary neuron can do everything, so don't worry about it. For simplicity, now we will start from the binary neurons. Okay, that's the reason, because it is simple. That's the reason. Okay. So anyway, you have to remember all of these things because this is very important, and you have to also remember that how it performs. It is also very important, so you have to remember. And also, the x1, x2, xn, yes, this is a real number. It can be a positive number or it can be negative numbers, okay? Or the w's, yes, it is any kind of real number. It can be any kind of real number. It can be a positive number, it can be a negative number. Okay, that's not important. So x1, x2, xn, w1, w2, wn, this is a real numbers, okay? So the reason why I put down 0, actually this is not 0. As I told you the last time, actually it should be, I said that here is some bucket, okay? Here is some bucket, and then there is a signal. If the signal is coming through, actually the xiw1, x2w2, this is amount of signal, right? And xn, wn, if the signal is coming through into the neuron, then the signal accumulate into some kind of buckets, right? So, and then I said, if the amount of signal reaches some threshold, then here is a gate or door opened, and then all the signals will go out, right? That is how the neurons work. So there should be a threshold age. It is very important factors, right, for the neurons functionality. But here I set the threshold as 0. Why I set the threshold 0 is simple, because this is a real number and this is a real number. So think about this. The S can be the summation of all the signal, because the X can be the positive or negative. W also can be positive or negative. So the summation S, it can be any real numbers, right? It can be any real number. So simply, if we set the threshold to 0, no problem, it's enough. So actually, I have to explain why the 0 is enough. Mathematically, I have to, but I will skip this because this is not so important and this is a little complex. So here, let's just remember that the 0 is enough as a threshold. So simply let's set the threshold 0, okay? So you have to remember this formula. This formula and this figure, actually they mean the same thing, okay? So as I told you, this is not figure. This is not figure. This figure and this formula are equivalent, okay? Actually, if you see these figures, you have to do some calculation. Which calculation? First, multiplication, and then summation, and then activation, and produce the output 1 and 0, okay? That is what you have to whenever you see this figure, okay? Whenever you see these figures, you have to perform some calculation. Multiplication, summation, activation, and produce the result, okay? That's what you have to when you see this figure, okay? This figure is not a figure. This figure is a formula, okay? This is a formula. Actually, this and this are the same thing, okay? So do not just see the figures. You have to perform some calculation. It is also important. Okay, so, and I told you that what a perceptron can do, right? Okay, here, if you set up the connection weight, the W1 equals 1.0 and W2 1.0 and W3 minus 1.0, then this neuron will perform the AND operation, right? I told you the last time, 맞죠? And also, if you change the connection weight like this, then this perceptron will perform the AND operations, right? And also, I did not explain But also you can make the negation, the inverter, not operations. If you set up the connection way like this, then this neuron will perform the negations, the inverter, right? It negations, operation of negation. So now you can build up with the perceptron, the AND operator, and the OR and the negations. Okay, these three, the logical operations you can implement. You can implement with the perceptrons. Okay, so now let's go back to the neural networks. Okay, there is a neuron. Okay, there is a neuron, one neuron here, and then here is another neuron. Here is another neuron, and then 뭘로 할까? And then here is another neurons like this. Here, so I put down the three neurons, and then next, these are the another neuron. This is another neuron. So the output of these neurons, output of these neurons are used as the input of these neurons. Okay, this neuron and this neuron are connected, and these are connected, and these are connected as neurons are connected in our brain. So let's connect these neurons, and then let's also connect these things, and then 야, 눌려라. 뭘로 할까? 요걸로 할까요? Okay, and then like this. Okay, so now in this neural network you see the 6 neurons, and each neurons, how do they work? Step 1, multiplication. Step 2, summation. Step 3, activation. Okay, here is, you see that there is a lot of connections, right? I do not write down all of things. Here, there are connection weight. Every connections, they have their own connection weight. Even though I do not write down, you have to remember that every connection has its own connection weight. Okay, here is a connection weight, here is a connection weight, here is connection weight, connection weight, connection weight. In every connection there is a connection weight. You have to remember. Okay, so how this neural network works? Simple. Input connection weight, input connection weight, input connection weight, summation and activation. So the output of this node is determined 1 over 0. Okay, and then next, what about this? Same thing. You have to repeat. Input connection weight, input connection weight, input connection weight, summation and activation. That output will be created here, 1 over 0, right? And also input connection weight, input connection weight, input connection, summation and activation. So here the output of each node are determined, right? 1 over 0, 1 over 0, 1 over 0. And then next, this node will perform this calculation. Input connection weight, input connection weight, input connection weight, summation, activation, input connection weight, input connection, blah blah blah. And all these nodes, also output of all these nodes will be determined, right? That is how neural networks works. Okay? Complex or simple? 복잡해요? 별거 아니에요. 빨리 말해. 모르겠어? 단순하죠? 네. 여기까지 이해가 안 되면 매우 곤란해요. 네. 수강 철회가 언제까지죠? 이번 주까지인가요? 네. 교수 하는 말이 못 알아듣겠다. 네. 그러면 철회를 하시기를 강력히 권고를 합니다. 아시겠죠? 왜 그럴까요? 여기까지 이해가 안 되면 앞으로의 14주는 무지하게 험난할 거기 때문에, 그래서 여기까지 이해를 해도 험난할 텐데 여기가 이해가 안 되면 무지하게 험난할 거거든요. 그러니까 괜히 고집피고 앉아있지 말고 이렇게 철회를 하세요. 알겠죠? 철회할 생각이 없으면 정신 차리고 잘 들으세요. 알았죠? 그 다음에 내가 또 말했지. 여기서 쳐다보면 여러분이 어떻게 보인다고? 여러분이 어떻게 보인다고 그랬죠? 벽에다가 여러분 얼굴을 그려놓은 것처럼 보여요. 무슨 말인지 알겠죠? 네, 벽에다가 여러분 얼굴을 그려놓은, 그 벽을 내가 보고 있는 느낌이에요. 그거는 상호 안 좋아요. 여러분들 안 좋고. 야, 너는 강의나 하지 뭘 자꾸 떠드냐라고 할 것 같은데 아니라고 그랬죠. 수업은 뭐라고? 수업은 뭐라고 그랬죠? 그래서 잊어먹었어? 대화라고 그랬죠. 대화하는 겁니다. 우리는 대화를 하러 여러분이 이 자리에 온 거지. 내 떠드는 거 공연하는 거 보려고. 사실 공연도 대화잖아. 그죠? 연극 가봐요. 관중이 이렇게 앉아있으면 앞에서 연극하는 사람도 얼마나 피곤한 줄 알아요? 저 사람들 왜 저래 하면서. 우리는 대화하러 여기 온 거지. 여러분이 나 떠드는 거 보러 온 거 아니죠. 적극적으로 대화에 동참해 주길 바래요. 그냥 넌 떠들어라. 난 듣고 있는데 뭐 내가 네 수업 방해했냐. 왜 자꾸 그러니. 이런 이상한 자세를 앉아있지 말고 적극적으로 동참해 주기 바랍니다. 아시겠죠? 지난 시간에도 말했지만 3년간의 온라인 수업의 폐예요. 폐. 그러니까 여러분이 대면 수업이 뭔지를 이제 이해를 못하고 있는 거야. 대면 수업하고 온라인 수업 차이가 뭐야? 난 듣고 있는데 이런 거지. 다르다는 거예요. 적극적으로 참여해 주시기 바래요. So anyway, the neural network is very simple. How a neural network works? Very simple. For every neurons, you have to perform the 3 steps: multiplication, summation, activation, and repeat that operation for all the neurons. Then you can determine the output of neural network. Because these are neural networks, how to determine the output of neural network is very simple. Just repeat the step 1, 2, 3 for every neurons, right? Okay. Then I said that these neural networks are equivalent of computers, right? 너무 많이 줬다. Computer. 왜 이러니? I said computer. 펜을 바꿔달라고 했던가 해야지 이거. Okay, the neural networks and a computer, they are equivalent, right? Can you prove this? Can you prove this? How this neural network can do everything a computer can do? Is it possible? Can you prove this? 증명 가능하죠? 왜? Because yes, you can prove this. Why? Every neurons can do and or negation operation, right? So every neurons can do and operations or operations or negations, right? Which means that okay, let's say it performed the AND operation. Let's say this can the OR operation or this perform the negation. Or okay, this is negation or an AND operation. You can set up like this, right? Then what is this? This will be a digital circuit, right? This will be digital circuit. What is a digital circuit? Computer. Computer is a digital circuit, so you can build up any kind of digital circuit if you have and or negation 3 operations, right? Yeah, only 2 operations is enough, and or negation. If you have only the AND gate or negation, not gate, then you can build up any kind of digital circuit, right? I believe that you already have learned this fact, right? In a digital circuit. 논리회로 디지털 서킷 맞죠? Okay. Or if you have only or the negations, this is enough to build up any kind of a digital circuit, right? Which means that neural network can do any functions that a digital circuit can do, right? So this is end of proof. Neural network and digital computer, they are equivalent. Okay, they are equivalent. So now you have to remember that a neural network can do everything that a digital computer can do. So it's a ability. Yes. So now this is very important. Why? Whenever you use a neural computer, you have to ask, well, this neural network can do this task. Every time when you use neural network, you have to ask, this neural network can do this task. Is it true or false? Every time you have to ask about this, right? Why? If this neural network cannot solve this task, then you have to stop, right? You have to stop to use the neural network. But now I answer to the question. Don't worry about it. Neural network can do everything that a computer can do, right? So this is a very important statement. Okay, and then maybe the next question. Okay, this is very interesting. This neural network and a computer, they are equivalent. Then why do I use a neural network? I already have a good and cheap digital computers. Many computers you already have, right? First, you have a cell phone. This is a computer. You have these computers, and you have a notebook, or you have the tablet PCs, or the personal PC desktop computers. You have a lot of digital computers. Then why do I need neural networks? As the power of a neural network, they are the same. Then why do I need neural network? What's the answer? 왜 우리 뉴럴 네트워크 필요할까요? 남들이 써서? Yep. 변경 가능해서. 컴퓨터는 변경 못하나요? 틀렸다는 얘기가 아니에요. 구박 주는 거 아닙니다. Okay, that's very interesting. Yeah, that's very close to my answer. What he said is that it's somewhat changeable or somewhat programmable. Yeah. Okay, in digital computer, here is a computer. Yeah, if you want to use a computer, you have to make some program, right? You need a program. Without program, the computer is just nothing. Yes, computer is nothing. If you do not have program, the computer is nothing, right? It's useless. Okay, then who build a program? If I give you a homework to make a program something, then who will make the program? If I give you a programming homework, then who will build up the program? Your friend, right? Your friend, and you will copy it, right? Okay, my point is that who make the program? Human being. Human should write the program, right? If you want to utilize a computer, then you have to make a program. This is a bottleneck. This is a bottleneck for the utilization computer, because human beings are very lazy and very slow, right? They do not like to work, so the making program is very slow, right? So that's the bottleneck of utilization computer. The bottleneck is a human being. Unfortunately, every computer should be built by human beings. That's the very sad news for the computers, right? But in case of a neural network, I said neural network is also a computer, different kind of computer, right? I said because computer and neural network, they are equivalent. We may say that neural network is another types of computer. That's true. Then neural network needs a program. What do you think about that? Computer needs a program to work. Then what about neural network? Will the neural network needs a program also? Yes, that's true. Why? Computer and neural network, they are equivalent. So computer needs a program. So neural network needs a program. That's true. Neural network needs a program. So if you want to use a neural network, you have to make a program, right? You have to make a program. Then there is a difference. This program, who will make a program for the neural network? Who will make a program for computer? Who will make a program for the computer? You have to make the program. Then what about the neural network? Neural network is another kind of program, a computer. So it needs a program. That's true. Then who should make the program? Who should make the program? You? Nope. Neural network by itself. So you don't need to make a program for neural network. Neural network by itself make its own program. Wow, it sounds very, very interesting, right? So what is a neural network? It's automatic programming machines. Yeah, wow, it's very interesting, right? Neural network is a computer, that's true, but it can make its program by itself. It can make its program by itself. That's why we use a neural network. We don't need to make a program for the neural network. Neural network itself make its own program, right? So what a wonderful machines. That's the reason why we use a neural network, okay? So the programming here, the process to make a program is called programming, right? Programming. What is programming? It's some process to make a program. Then in this way, in this side, the process to make a program is called training. Training. N이 두 개냐 하나냐? 하나죠? Training. It is called training. The process to make a program is called training. So in case of a computer, you should do programming, right? You should do programming. But in case of a neural network, you should do training. You should do training. That training means that training a neural network means that making a program for neural network that are equivalent. So usually you already have heard about the training or training neural network or something, right? What is training about neural network? It is making a program. It is process making a program for neural network. Okay, so training means making a program. Okay, you have to remember. Okay, it sounds great, but where is program in neural network? In a computer, there is a CPU and there is memories or blah, blah, blah. So and there is a compiler, right? So I make some program, then the compiler translates to the machine languages and I load it to the memories and the CPU will execute the program something, something, something. But there is no memories, there is no CPUs, even though there is no programming languages, right? Then where is a program? What is program? Where program exists in neural network? That maybe you have some questions, something like these things, right? Okay, then let's go back to here. Okay, this neural network, okay, you have to look at this. This is AND operation. This neural network performed AND operations, right? And then this one, this neuron performed AND operation. Okay, let's compare two neurons, AND or AND. Okay, just look at this part. Just look at this part. Do not see other parts. Okay. Okay, this is AND operation, AND or which are different. Where are different? AND or where are different? 뭐가 다르죠? W3 W3 different. Another way, connection weight. The connection weight different. Okay. Okay, here if you okay, let's say this can be compared to the hardware. Okay, hardware are the same. Here, look at this. AND operation or operation, the hardware are the same there. So we can say that these are the hardwares, okay? Which part is different? The connection weight. Connection weight, this is a connection weight for AND operation. This is connection weight for OR operations, okay? AND operation, OR operation, AND operation, OR operation. Which part is different? Connection weight are different. This connection weight different. So this can be considered as software. So in this hardware, if you load this software to here, that it perform AND operation, and for the same hardware, if you load this connection to here, then this hardware perform OR operation. Very similar, right? This is a computer, and let's say this is a PowerPoint. If you load PowerPoint, then this computer is somewhat the presentation software, right? It acts, it behaves like a presentation software. And to this computer, if you load a word processor, so for example, Microsoft Word, if you load this to here, then this computer behaves like a word processor, right? So the connection weight is software for the neural network. So if you change the connection weight, its behavior, the functionality of a neural network will change. Then some of you may ask this question. But yeah, it corresponds to software, but this is not software, right? This is correspond to hardware, and this is correspond. We may say this is correspond to software, but this is not software. You may say like that. Is it software or it just correspond to software? What's your opinion? Oh, yeah, that's a software. Yeah, I agree. No, this is not software. It may correspond to software, but this is not software. 어떤 게 맞는 것 같아요? Maybe you prefer number 2, right? This is not software. Yeah, I agree. This may correspond to software, but this is not software. You may think so, but this is software. This is software. Definitely, this is software. I will prove this. Okay, what is software? Do you like C program? For example, main, blah, blah, and int, IZ, or printf, blah, 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 blah. Okay, you think that is a software? No, this is not software. Computer does not understand, cannot understand this program. Okay, so you have to translate the program into machine languages. Machine language is number, right? Machine language is number. Okay, I'll write down in a hexadecimal numbers. For example, OXFF, OXDA, OX12, OX2E, or OX3F, blah, blah, blah. Okay, you have to translate into binary numbers. So, for digital computer, this is a software, right? Agree? 동의해요? Okay. This is sequence of numbers, right? Sequence of numbers. These are software. Do you agree? 동의해요? Okay. What are these? What are these? Sequence of numbers. Agree? Do you agree? Then, is it software or it is not a software? It is software, right? It is software. True, it is software. The connection weight is software. And if you change the connection weight, the functionality of neural network will change as digital computer changes functionality. If you change the programs, right? That's true. So, in a neural network, what is the most important things? Connection weight. Connection weight. Even though you have the same neural network, if you change the connection weight, this neural network will perform the dog and cat differentiate. It will differentiate. It will be differentiator of cat and dog. Even though these are the same neural network, if you change the connection weight, this neural network will be a stock index predictor. Okay? Even though this is the same neural network, if you change the connection weight, this neural network will be GPT-3. Okay? So, in a neural network, the neural network itself, that's not important at all. What is important? The connection weight. Here, the connection, which value you have to put down here, the values you put down here, that's the connection weight. If you give different connection weight here, that this neural network will do different functions. If you change the connection, value of a connection weight, for example, 1.0, 1.3, minus 1.0, 1, 2, 3, real number. Connection weight is a real number. So you change the connection weight, the value of a connection weight, I mean, then the functionality of a neural network will change. That's a very important question. Okay, very important factor. Okay, so this is overall of a neural network. How neural network works? Very simple. Step 1, 2, 3, multiplication, sum up, and activation. And then repeat this calculation for every neurons. Then that's how neural network works. Okay. Then what is the connection weight? Yes, it's a program for neural network. So if you change the value of a connection weight, the functionality of a neural network will change. It can be a dog and cat differentiator, or it can be stop index predictor, or it can be GPT-3 or anything. If you set up proper value for connection weight, okay, that's very important. This is the all things human beings know about 1960s. In this era, this is the year, not the exact year, around 1960s. This is the birth of a neural network, and researchers, they know about all of these things. Wow, this is a new types of computers, and then if we change the value of a connection weight, then it can do anything as digital computer that digital computer can do. This is all the fact that the researchers have known around the 1960s. Okay, 그러니까 여태 배운 게 60년 전 거 배운 거예요, 여러분은. 슬프죠? 아닌데 딥러닝은 되게 최신인 것 같죠? 최신 얘기를 들을 줄 알았죠? 아니에요. 네, 60년 전 얘기부터 시작을 해야 돼요. Okay, then what question will be next? What question do you have in mind? 질문 없어요? 진짜? 이쯤 되면 질문이 나와야 되잖아. 여러분이 인간이라면. 질문 뭐 떠오르는 거 없어요? What? Okay.
그 W 숫자하고 열이 바뀌는 게 그게 소프트웨어라고 하셨잖아요.
네.
예를 들어서 히든 레이어가 늘어나거나 아니면 인풋되는 X 값이 늘어나는 것도 커넥션이 바뀐다고 하셨어요.
Oh yeah, he asked this. Okay, then here is we have only two layers. I did not explain the layer structure yet, but we have, you see, only the input. Input is not a layer, okay? Here is a 2 layer. Then what about the 3 layer here? Yeah, that's not important. The number of layer. Okay, how many layer do you want? How many layer do you want? 10? 100? 1000? No problem. You may put down there. But still, that's not important. What is important? Connection weight. Connection weight is the most important thing. So, okay, connection weight is the most important thing. The structure of a neural network, actually, that's not important at all. That's not important at all. The most important thing is connection weight. Connection weight. If you change the connection weight, then the functionality of a neural network will change. Okay. Okay. Later, I will talk about the structure of a neural network, and also structure of a neural network is important. Right, is important, but we may say like this. Here is a CPU for supercomputer. Okay, this is a CPU for supercomputer. Here is a CPU for mobile phones. Okay, mobile phones. This is CPU for mobile phone. We have two different CPU. Let's say one is CPU for supercomputers, and one is the CPU for the mobile phone. Are they different or they are the same? In a theoretical viewpoint, not a practical viewpoint. In a theoretical viewpoint, CPU for the supercomputer and the CPU for mobile phone, are they different or the same? In a theoretical viewpoint, they are the same. They do the same thing, right? In theoretical viewpoint, they do the same things, right? But in a practical viewpoint, they are different. Why? In a supercomputer, it has a lot of memories and it has a lot of power. But in mobile phone, there is a limited amount of energies and there are limited amount of memories. So in practical viewpoint, the CPU for supercomputer, CPU for mobile phone, they should be different. That's true in a practical viewpoint. But in a theoretical viewpoint, they're the same. They do the same thing, right? Actually, they do the same thing. Yeah, that is. If you have a lot of layers here, if you put down a lot of layers here, this is something like CPU for supercomputer. If you put down just a small number of layers, if you put down just small number of layers, just small number of layers, like this, only 2 layers, this is something like the CPU for mobile phones, okay? That's the difference. How number of layer different? In a theoretical viewpoint, they are the same. The number of layer, that's not important. In a theoretical viewpoint, they are the same thing. But in a practical viewpoint, oh, they are different. They are different. If you put down a lot of layers, it's something like CPU for supercomputers. So its power is strong, but it needs a lot of energies. It needs a lot of memories. And if you put down the small number of layers in a neural network, it's something like a CPU for mobile phone. So its power is very weak. Its power very weak, but it consumes less energies. It consumes less memories, right? Yeah, they are very similar things. But now I'm talking about in a theoretical viewpoint, okay? Not a practical viewpoint. In a theoretical viewpoint, the most important thing in neural network is connection weight. If you change the connection weight, value of a connection weight, then the functionality of a neural network will change. That's the point, okay? Okay. What question will be next? Should be. Okay. 네. 오케이. 질문이 너무 나가고 있는데요. 괜찮아요. 좋아요. 농담한 겁니다. What he asked to me is this one. Then here, okay, here is on a neural network which has only 2 layers, one and two layers, something like this. Okay. And here is a neural network which has many layers. Okay. Are they equivalent? Can you prove this? What do you think about this? It's possible. Yes, they are equivalent. Yeah, but there is some conditions. If you put down a lot, of node here, how many? It depends on the situation, but if you put down a lot of node here, but then this is deep neural network, and these are shallow neural network. Yeah, deep and shallow. Deep network and shallow network, they are equivalent, and they perform the same things. If you can put down a lot of nodes here, then shallow network can do everything that deep neural network can do. Then why do we need deep neural network? This is in theoretical viewpoint. In theoretical viewpoint, shallow network and deep network, they are equivalent. Shallow network can do everything that deep neural network can do in theoretical viewpoint. Can you catch the nuance? In theoretical viewpoint. But in a practical viewpoint, nope. In practical viewpoint, nope. Why? Cell phone can do everything that supercomputer can do? Nope. Nope. That's not true, right? In theoretical viewpoint, wow, yeah, same thing. So supercomputer and cell phone, they are the same thing in a theoretical viewpoint. That's true, right? But in a practical viewpoint, really, cell phone can do everything that supercomputer can do? Nope, that's not true. Yes. So in a practical viewpoint, Shallow network cannot perform everything that deep neural network can do. Yeah, that's not true in practical viewpoint, but in a theoretical viewpoint, that's true. Shallow network, deep neural network, they are the same thing. Digital computer, all of these are the same thing, but there is some difference in a practical viewpoint. And what are they? How they can be different? Yeah, I will explain later. But now, let's focus on a theoretical viewpoint. Okay? But they are the same thing. Okay. Then the question will be this. What? How to set the connection weight to perform the dog-cat differentiator, right? This is very important. Okay, you said the connection weight important, and if I properly set up the connection weight, then neural network perform. The neural network will be dog-cat differentiator. If I properly set up the connection weight, then this neural network will be stock index predictor. If I properly set up the connection weight, then this neural network will be GPT-3. It sounds very interesting. Then how? How can I set up the connection weight to perform so that this neural network perform the dog-cat differentiation, okay, or stock index prediction, or language models. 언어 모델이 뭔지 알아요? Language model. Do you know what is the language model? In AI, we use this terminal, language model. It sounds very interesting, right? What is the language model? What's this? This is GPT. Yeah, the GPT-3 or ChatGPT you use, right? Yeah, they are language models. I will talk about later what is the language model. But anyway, language model, ChatGPT is a language model. Or Bart is the language model. Everything is a language model, okay? These are everything is the language model. Okay, next question should be this. How to set the connection weight, right? This is a very, very important question, right? If you cannot set up the connection weight here, then neural network will be useless, right? I want to make this neural network a dog-cat differentiator, but I don't know how to set up the connection weight. Then you cannot perform the dog-cat differentiation with the neural network. If you do not know how to set up the connection weight, then you cannot make this neural network. You cannot make a GPT-3 with this neural network. So this is very important. How to set up the connection weight. So that's the sad story. In 1960s, this is the birth of a neural network. But at the time, they did not have any idea. On how to set up the connection weight of a neural network. Okay, they do not know. Did not have any ideas. That is, which means that they do not have training algorithm. Around 1985, error backpropagation. Yes, this is the first training algorithm. So at that time, now human beings can train the neural network because we have training algorithms. So neural network, there is a birth of neural network, but it died right after. Why? We do not have the training algorithm, which means that we cannot set up, at that time, we cannot set up the connection weight, which means that we cannot make a dog-cat differentiator with a neural network. At the time, we cannot make a stock index predictor with a neural network. At the time, we cannot make GPT-3 with a neural network because we cannot set up the connection way here. But 1985, now a first training algorithm, this way, a training algorithm to set up the connection way was proposed. So here, the first boom of a neural network. So neural network was popular after the 1985 because here is a neural network and I can train the neural network, which means that I can set up the neural network, the connection with the neural network, and then I can make a dog and cat differentiator with the neural network. What do you want? I can make it for you. That's possible at the time, right? But in the year around of the year 2000, another, there is a death or waiting. There's another way, the collapse. So anyway, I'll talk about this later. So now let's focus on the here. Okay, last week we focused on this topic. Okay, the neural network, the year of 1960s. We focused on the topics, but now let's move to 1985. There, the first training algorithm was proposed. So next topic will be training algorithm, how to set up the connection way. Okay. So we may say that perceptron can solve a linearly separable problem. You may understand the meaning of a linearly separable problem. Why? I told you this W it can represent a line in an input space x1 and x2, right? So if you give every input above the line, then neural network will produce one output as an output, and if you give all the input which is below the line, then neural network will produce zero output, right? So this is for this we said that perceptron can solve linearly separable problems. Okay. Okay, then you may have some other questions. What about this? The exclusive OR. For example, this is x1 and x2, x1 and x2, y. Okay. And 0, 0, exclusive OR will be 0, right? This is exclusive OR. 0, 1, the output will be 1, 1, 0, 1, 1, 1, 0. This is exclusive OR operations. And also, if you draw this operation in a x1 to input space, here is 0, 0, 0, 0. Red means that the output of 0. And the 1, 1, this is 1, 1, right? 1, 1 point. And the color is red, which means that output should be 0. And then 0, 1, 1, 0, the output should be 1. So here. Okay. Then do you think that a perceptron can solve this problem? Perceptron can do this problem, exclusive OR? No. Perceptron can solve a linearly separable problem, which means that if you can separate red and blue with just one line, then a perceptron can solve that problem. But unfortunately, this problem, you cannot separate red and blue with just one line. Yes. So, for example, like this, nope. The red and blue are not totally separated. What about this? Nope. No. So this is non-linearly separable problem. This is a non-linearly separable problem. For example, if you have something like this curve, then you can separate the red and blue, right? Okay. Or for example, this one, no problem. Anyway, what is important? This is a non-linearly separable problem. Okay. Then, if you have a non-linearly separable problem, what will you do? At the time, if you use a neural network like this, then it can solve non-linearly separable problems. Why do we use a neural network? For this one. if you have a non-linearly separable problem, then you have to use neural network. But if you have a linearly separable problem, linearly separable problem, then you do not need neural network. A perceptron is enough. If you have a linearly separable problems, a perceptron is enough. But if you have non-linearly separable problem, yes, you have to have neural network. Okay, can you set up the connection way? The W11121322 뭐냐 이거? 21? Yes, 212223313233. Can you set up the connection way, the W's, so that this neural network perform the exclusive OR? A similar problem was given as a homework. 숙제 확인 안 해봤어요? 안 해봤어요? 네, 숙제 있는데 봤죠? 숙제 있어요? 이런 사람도 있는 것 같은데 있어요. Okay, let's think about this. Which value is needed for exclusive OR? Can you set up the W? W111213, W212223, blah blah blah, everything, every connection way for exclusive OR. Can you do this? 할 수 있겠어요, 없겠어요? 할 수 없어요라는 말이 막 나오는데 자존심 상해서 못 하고 있죠. 네, 내가 묻는 이유는 뭘까요? 못 하겠어요라는 말이 나오기를 원하는 거예요. Yeah. Can you set up all this connection way? Maybe, but I do not want to do. Why? It looks very complex, right? Actually, the exclusive OR is very simple operation, right? It's a very simple operation. Even for this simple operation, determining the connection way, the neural network is very, very complex. So, what about the dog and cat differentiator? You want to make a dog and cat differentiator. Okay. Differentiator. Then can you determine the connection way for dog and cat differentiator? No, it's impossible. Why? For simple exclusive OR, the setting up the connection way, the determining a connection way is not easy. But dog and cat differentiator is very complex problem. Then how can you set up the connection way? It's impossible. That's why we need training algorithm. If you use training algorithm, then the training algorithm automatically determine the connection way. Wow, it sounds great, right? If you run the training algorithm, then the training algorithm automatically set up the whole the connection way for you. So I told you that the connection is software, right? It's a software. The training algorithm automatically determine the connection way. So which means training means that programming. Training and the programming are equivalent. Why? They determine the connection way. Connection way is software, right? So training algorithm is the most important thing in neural network. Okay. I already told you that. This is a multi-layer perceptron. It is a layered structure. This is a very popular structure of a neural network. So here it is a layered structure, right? Here is one layer. This is another layer. Input is another layer. Input is just input. So we call this is output layer. Why? These are the output of a neural network. So the layer which produce output, so we call this output layer. And we call this a hidden layer. Why? It is hidden between the input and output, right? It exists between the input and output. It is hidden between the input and output. So we call this a hidden layer. So here, one hidden layer, one output layer. So it has two layers. Okay, this is not three-layer structure. This is not. This is two-layer structure. One hidden layer, one output layer. Two-layer structure. Then can we put down one more hidden layer like this? Yes, no problem. Then it is 3-layer structure. 2 hidden and 1 output. 3-layer structure. Okay, what about this? No problem. You may put down as many hidden layers as you want. No problem. Then what about the node? How many nodes may I put down here? No problem. You may put down as many as nodes you want. Okay, number of layers, number of nodes. Yeah, you can put down as many as you want. Okay, so if you put down one hidden layer, or 2 hidden layer, or 3 hidden layer, maybe then you may say this is a shallow network. This is shallow neural networks. Okay, you may put down the more hidden layers here. Then this will be deep neural network. So shallow network and deep neural network, they are the same thing. Only the difference is number of hidden layer. If you put down many hidden layer, your neural network will be deep. If you put down small number of layers, then your neural network will be shallow. Okay. Then I put down 5 layer here. Okay, I put down the 1, 2, 3, 4. Yeah. Here is a 4 layered neural network. Is it shallow? Is it deep? That question is meaningless. There is no definite criteria. There is no definite criteria for shallow and deep. Shallow and deep is a relative concept. Okay, it's a relative concept. Here is a 20-layer structure. 10-layer structure is shallow. Here is a 10-layer structure, but here is a 5-layer structure. 10-layer structure is deep. Okay? So shallow and deep is not an absolute concept. It's a relative concept. Okay? So please don't ask me 3-layer structure is shallow or deep. That's not important at all. Okay? It's just a relative concept. So please remember. And also, if you see here, there is no connection between from here to here, right? There is no connection here from here to here. But you said that in our brain there is a neuron, and neuron is connected some randomly connected. Okay, they are connected to neighboring neurons, but in some random pattern like this. But this neural network, it does not look like there is some the rules, right? There is some rules. So you may think that this structure of neural networks and the structure of neurons in our brain, they are not same. They are different. Yeah. But here, yes, you may do anything. Why do we use a layered structure? For simplicity. Okay? If you use a layered structure, it is easy to manage. It is easy to train. But this is not important. Okay, if you want, you may put down any connection. If you put down any connection, okay, this, no problem. Yes, as in our brain, you may put down this, no problem. Yes, what about this? This, yes, no problem. You can connect from any node to any node. Yes, the layered structure is not important at all. You can connect every node as you want. You can connect every node. Okay, which means that the structure is not important. Structure is important. Why do we use layered structure? Because it is easy to manage. Because it is easy to train. But the structure itself, that's not so important. You can connect any node between any node. But there is one exception. Do not connect this node to this node. No, this kind of connection is impossible. No, not impossible. It's possible, but I strongly recommend do not use this kind of connection. You can connect every node except this type of connections. Okay? Why this is not permitted? Simple. If you connect these two nodes, there will be a loop, right? Input, output, and output loop back to the hidden layer, and then there is a loop, right? If there is a loop, that is not permitted. A connection which make a loop, that is not permitted. Why? Simple. For example, here is the input, and let's say the output is 1, and then the 1 is go back to here, and then blah 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 recalculate it, then the output may be changed to 0, right? And then this output 0 may goes back to this node, and some calculation will be re-performed, and the output may change 1. So if you put down this kind of loop connections, then the output of a neural network may be oscillate 1 0 1 0 1 0. Yes, if you are lucky that the output may be stay at 1 or may stay at 0, that's possible. But if you are unlucky, the output value may oscillate 1 0 1 0 1 0 1 0. So we cannot determine the value of output. So that's the reason you should not use the loop connections. Without this one, you may use any connections. Layered structure, that's not important at all. You may use any connections. Okay, you may connect this. Yes or no? This one. Yeah, it's possible. Why? There is no loop. There is no loop. Okay, then what about that? You may put down this. You may put down this like this. But here, let's put down another connection. What that is? This one. Is it okay or this is not okay? This is not okay. Why? There is a loop, right? There is a loop. So without the blue one, yes, it's okay. No problem. You may use this. But here, if you add one more connection like this, then there will be a loop. So this is not permitted at all. Okay? 질문. Do you have any questions? This is end up. 18장을 3시간 갖고 있죠. 1시간에 6장씩밖에 안 나간 거야. 질문 없나요? Okay, this is introduction to neural networks. So now I will go forward to learning algorithm. I told you the most important topic in neural network is training algorithm. This is the most 말고 더 most는 뭐냐? Extremely most. Very important topic. This is training algorithm. Okay. So next topic will be the training algorithm. There are algorithm. Okay. There are many training algorithms. But the most popular training algorithm is error back propagation. So in training algorithm, there are many. Yes, there are many training algorithms. That's true. But the most popular training algorithm is error back propagation. I think that 99.99% may use error back propagation. 다른 알고리즘이 있다는 얘기일까요? 없다는 얘기일까요? 없다고는 할 수 없으나 없는 거나 마찬가지다 라는 얘기겠죠. 없다고 있어요. 있는데 도저히 쓸 수 있는 알고리즘들이 아니에요. 그냥 뭐 책에나 존재할 수 있는 알고리즘들이란 얘기겠죠. So anyway, maybe the error back propagation may be the unique training algorithm. In theoretical viewpoint, you may use many different training algorithms. Yes, that's possible. And also, many researchers, they already tried to develop another training algorithm. But theoretically, they were successful. But in a practical viewpoint, they failed. So there are many algorithms, but this is not practical. This is not practical. But this is practical algorithm. So that's why most people use error backpropagation. Okay. So this time I'll talk about the error backpropagation algorithm. This is a very important topic in neural network. Okay, the learning algorithm. This is an overview of a learning algorithm. This is a neural network. So you determine the hidden layer, the number of hidden layers, and then you determine number of nodes. Okay, you have to determine the structure of a neural network. You have to determine the structure of a neural network. The number of layers, yeah, you have to determine, and the number of nodes in hidden layer, yes, you have to determine this. What about then? What the training algorithm do? For me, training algorithm, they determine only connection values. They determine only the connection value. They determine on the connection values, connection weight, value of connection weight between the node. Okay, so also you have to, once more, you have to remember that number of layer, number of node, you have to determine. Okay, then there is an initial neural network. This is a student. This is a student. Okay, if we compare to human beings, the neural network is a student. And so this is the brain of the student. Okay, then you have to determine the structure of a neural network. Then what about the connection weight between the node in an initial neural network? We do not know the connection weight, right? So in initial neural network, you have to randomly initialize. The connection weight here, yeah, randomly, you have to determine the randomly initialize the connection of a neural network. Okay, this is a starting point. Okay, once more, you have to determine the structure of a neural network, and you have to determine connection weight with the random values. Okay, that, let's call it initial neural networks. Okay, and then you have to prepare training data. This is training data. This is a training data. For human being, it is textbook. This is student. Okay, then what do we need? Here is a student, here is a textbook. What do we need? A teacher, right? A teacher. Training algorithm can be considered as a teacher. But teacher is not a good teacher. This teacher is not a good teacher. The teacher always says, this teacher always says that memorize textbook, memorize textbook, memorize textbook, memorize textbook, textbook. It is important. So you have to memorize. How many times? 1 million times, 10 million times, 100 million times. Repeat, memorize. So the teacher is not a good teacher. Very, how can I say? It's not good teacher. So, but anyway, the student is a very good student. So finally, he memorized everything. After all this process, this student neural network can memorize all of these things. So what does that mean? Yeah, here the connection weight will change. Okay, because the structure of a neural network, number of layer, number of node, do they change? No. Number of layers, number of node do not change. The structure of a neural network do not change at all. Then what will change? The value of connection weight will change. Okay, here is initial neural network. This is a neural network after training. How they are different? The value of connection weight. Value of connection weight. For example, in an initial neural network, the value randomly, I told you that you randomly initialize the connection weight. So let's say this is 0.1. The connection weight, this is 0.5, something like this. Then after training, the connection weight will change. How? I don't know. Maybe 1.0 minus 0.5, 1.5, something like this. Only the connection weight will change, and then the resulting memorizing of all these things. What does that mean? This. Okay, this is input data. So training data. So this part is input. This part is input. And this part is called output. Okay. And you have how many? N samples. You have N samples, right? Then the neural network will memorize all of things. What does that mean? This. Let's say this is D1. This is D1. And this is T1. Then if you give here D1, then this neural network will answer T1. Why? It memorized all the training data. If you give D2, let's say this is D2, so here, if you give D2, then the neural network will answer T2. It's wonderful, right? And if you give this Dn, this is input. If you give Dn, then neural network will answer Tn. 야, 어떻게 이게 가능할까요? 신기하죠? So this is what training algorithm does. Okay? Even though here is randomly initialized, so it does, and it never learned about this training data. But after the training, is you change all the connection weight like this, and then this neural network can answer to any question of this problem. So if you give the first samples, then it can correct answer for the correct first sample. If you give the second sample, then it can give you a correct answer, and then blah 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 blah. This is a result of training algorithm. Okay. So next time I will explain the training algorithm, how we can update the connection weight. Okay. Okay. Thank you. See you Wednesday.